Welcome to Lecture 13, 1.7, Linear Compound and Absolute Value Inequalities. Okay, so this is the last section for Chapter 1. So make sure to go ahead and go back and review all the lecture notes, all the examples that I had. Those are good sources for any type of problems that might appear on your exam. Alright, so note, when working with inequalities, it is very similar. That was supposed to be a pen, I'm not shaking the paper. It is very similar to working with an equation, except for one major difference: when you multiply or divide by a negative number. Okay, so when you multiply or divide by a negative number, what you have to do is you have to flip the inequality. Now, why do we do this? Well, let's just take a look at any inequality that makes sense first. Okay, in the sense that it doesn't have a variable, because usually we'll be working with an inequality that has a variable in between. But let's ignore the variable for now and just focus on just the numbers. So if I had 1 is less than, well, what's a number 1 is less than? 1 is less than 5, right? So normally you can do all the things you can do with equations. You can add and subtract numbers, you can divide numbers, but you cannot multiply or divide by a negative number without flipping the sign. So let's first try it without flipping the sign. Let's multiply both sides by negative 1. Why not? If I don't flip the sign, which remember is wrong, I'll get negative 1 is less than negative 5. Let's just check a number line for that real quick. So on a number line, we have 0, negative 1, negative 2, negative 3, negative 4, negative 5. So this inequality is telling me that negative 5 is greater than negative 1, which is actually not true. The farther back we go on the number line, the smaller the numbers get. This inequality isn't true. It doesn't make sense when I multiply by a negative number. So to balance that out, what we have to do is we have to flip the sign when we multiply by a negative number. So if I flip the sign, I'll end up with the inequality that says negative 1 is greater than negative 5. And does that make sense? It does. Negative 1 is greater than negative 5 because it is to the right of negative 5. Okay, so that's the reason why. Because of how negatives work with greater than or less than, you need to make sure to flip the sign when you multiply by a negative number or when you divide. So for multiplication and division. Let's take a look at the first objective. Solve linear inequalities in one variable. So solve the following linear inequalities, then graph the solution, and write the final answer in interval notation. So there's 3 steps here. So for solving, as I said, it's the same as solving an equation, except you just have to remember if you multiply or divide by a negative. So where's my variable? It's right there. I want to get everything on the other side of the equal sign, or the inequality in this case. So I have a 4 and a negative 6. So first, I'll subtract the 4 from both sides. Then I have negative 6m is less than 30. So I'm going to go ahead and divide by, oh, look at that, I'm dividing by a negative. Okay, so some of you, which is what I used to do, and I would get points docked off for this, some of you would decide to switch the step, or switch the inequality in the next step. The problem with this is that when you do it on the next step and not right here, this is no longer a true statement. So to balance that out, you need to make sure to flip the sign, or flip the inequality, in the very step you're dividing, okay? Please keep that in mind. So flip it in the step when you are actually doing the dividing. Okay, which means we have m is greater than negative 5. Okay, we've solved for m. Awesome. Now let's go ahead and do the graphing. I find it's easier to graph first and then read interval notation from the graph. Okay, so we have negative 5. I always like to identify 0. And then my number, the negative 5, and that says that m is... Now remember, think of your inequality as like a Pac-Man mouth. The Pac-Man always goes for the larger number, right? Munch, munch, munch. Which means m is supposed to be bigger. So all my values, my m values, are on the bigger side of -5, and they go on for infinity, so I use my arrowhead. And then the question, do I fill in the dot or not? I don't, because there's no line underneath. Okay, and there we go. Now let's take a look at the next inequality. I have fractions. Let's see. Well, if I was to multiply across to get rid of the fractions, would that be a problem? No, because I could pick a number I know, and then as long as it's not a negative, I wouldn't have to worry about flipping signs. So let's pick a common denominator to get rid of those fractions. It's going to be 6. And then because it's an equation, or an inequality in this case, I don't need to use the building up property. So I can multiply both sides by 6. And that's going to end up looking like 6 times x plus 1 over 3 minus, remember the 6 gets distributed in, 6 times 2x, oops, wrong color, 2x minus 4, all over 6, which is less than or equal to negative x over 2 times 6. We can go ahead and cancel out values and rewrite. So we have 2 times x plus 1 minus 2x minus 4 less than or equal to negative x times 3. Alright, I want to get rid of my parentheses. So let's go ahead and distribute in this step. I'll distribute that negative, then just multiply these two together, which will give me 2x plus 2 minus 2x plus 4 less than or equal to negative 3x. Now I'm going to go ahead and combine like terms on this side. So like terms, we have the x's and the regular numbers. So 2x minus 2x, those are gone. And then 2 plus 4 is going to be 6 less than or equal to negative 3x. Now solving for x, let's go ahead, we'll divide by the negative 3. Ooh, and when I do that, I need to change my sign on this step. I once again announce that because I will be checking this when I'm grading, so please make sure you do that. And then I have negative 2 is greater than or equal to x. Alright, I have to show my answer, interval notation and graphing. So once again, I always denote where 0 is. And then I have my value. Let's see. It says negative 2 is the bigger item because the mouth is facing the negative 2, which means my x values are less than. And it's an equal to. So there we go, fill in the bubble. Oh, I just realized I didn't write interval notation for my other problem. Let's go back and fix that. So I'm going to do interval notation for both of these. So for the first one, where do we start? Remember, reading from left to right. Well, we start at negative 5. Do we include it? No, we don't. So open parentheses, negative 5 to infinity. Now question, can I use a bracket for infinity? The answer is no. Why not? When you're including a bracket, you're saying that you can actually touch that number. You can include that number. The problem with infinity is it's not a number. It's a concept. So we can never actually touch a concept, as it were. So you have to use the parentheses. Now for this next interval, where do we start? Well, we don't know the smallest number. In fact, all we know is that it's negative infinity, which once again we use the parenthesis because we can't touch it. And then we go up to negative 2 and stop, but we include negative 2. Okay. Now let's take a look at objective 2. Solve compound linear inequalities in one variable. So compound linear inequalities. It's sort of a joined inequality. Alright, let's take a look at this one. Solve the following, graph solution, add your interval notation. Okay, so I'm going to solve each of these separately. I'll go ahead and, so if you wanted to, you could write or the whole way down. I'm not going to. I'm just going to draw a line and then write it at the very end, which I'll allow in this class. Once again, check with your professor on things like that, for whichever class you're in. So solving for x is less than or equal to 7. And then on this side, how do we get rid of that half? Let's multiply both sides by 2. Do we need to switch the sign? No, because I multiplied by a positive number, so no need to worry. The 2's cancel. I'm left with x is greater than 12. Here's where I bring in my or. And remember, what does or mean? Or is the union symbol. So let's graph both of these separately. I'm going to go ahead and indicate where 0 is. Then I have my 7 and my 12. And once again, I don't really care too much about using tick marks in a nice, even ordered out pattern for these kinds of intervals for inequalities. Unless stated otherwise, you can just give me a nice clear graph like this. Okay, so the first one, I'm going to go ahead and graph it in red. X is less than or equal to 7. So you could go ahead and pause the video and try to graph these two yourself and check with me. Or you can follow along. And the next one, let's graph that in blue. X is greater than or equal to 12. Actually, greater than 12. Alright. So I'm told to take the union of this. And remember, union, think marriage. Or is the same thing as union. That's going to be everything. So I just take what all of them have in what all of them have. Which means we go from negative infinity up to 7, include 7. And then we union that with the 12 to positive infinity. Now for B, we're using an AND statement. So let's say I'm just going to solve each side. Let's see, dividing both sides by 0.36. 0.36, what do I have? Using my calculator, 0.54 divided by 0.36, 1.5. So W is less than or equal to 1.5, and alright, let's look at this problem. Ooh, we're multiplying by a negative. So, I'm going to multiply both sides by a negative 2. And when I do that, I need to switch the sign. On this side, the negative cancels with the other negative, and the 2 cancels with the 2 in the denominator. And I'm left with W is less than negative 6. Alright, let's go ahead and graph this one. Once again, indicating where 0 is, and then 1.5 and negative 6. As usual, I don't really care too much about spacing evenly with the tick marks. Just let me know where 0 is, and then make sure your negatives and positives are on the right side of 0. I'm going to go ahead and graph this in yellow. This says W is less than negative 6 and not equal to. Now the other one says that W is less than or equal to 1.5. So it also includes 1.5, but it's less than or equal to. Now I want AND. AND is the same as intersection. Think of friends, only what they have in common. So what do these two have in common? Well, they agree right here. So from negative infinity, oops, wrong pen. From negative infinity up until almost at 6, but not including negative 6. And then we stop. Now let's take a look at one that is a slightly different looking compound. We don't have the word AND in it. And we're actually going to end up solving this a little differently. What happens is, if you subtract something from the inside, you need to do the same to all 3 sides. So it's like a super fancy equation. Every side needs to be treated the same. Just like if you have 3 kids, hopefully you treat them all the same. Unless one of them is under 3 years old, you probably shouldn't be handing them a knife. Alright. I want to get y by itself. How do I get y by itself? Well, what's keeping y from being by itself. The negative 4 and the negative 3. I want to get rid of those. As usual, always get rid of your addition or subtraction first. So let's do that. To get rid of a negative 4, I'm going to add 4. But once I do that, I need to do it to all three sides. So I have to add 4 to this side and add 4 to this side. So negative 16 plus 4 is going to be negative 12, less than or equal to negative 3y, which is less than 2 plus 4 is going to be 6. Then we can go ahead and, let's see, to get y by itself, I need to divide by, a negative. What happens when we divide by a negative? Gotta flip the sign. So notice, when I flip the sign here, it's still going to be a greater than, or it's still going to be the equal to kind of sign. And the other one that wasn't an equal to, we're just going to leave it without the line underneath. So it just changes direction, not the type. Negative 12 divided by negative 3 is 4, so 4 is greater than or equal to y, which is greater than negative 2. Does that make sense? Is negative 2 less? Yeah, let's take a look at this graphically. So what I'm going to do, I'm just going to rewrite this so it might make a little more sense to you. This is saying that negative 2 is smaller than y, and y is smaller than 4. So rewriting that, this is the exact same thing. I've just flipped it. Not changed any of the values. So let's graph that. Negative 2, 0, and 4. And my values I'm looking for are in between that. Not equal to negative 2, but they're equal to 4. So I can fill in the 4 with a bubble. Because remember, the 4 had the line underneath, and the negative 2 did not. And there we go. So let's go ahead and do the interval notation. Well, we start at negative 2, but we don't include it. And then we go all the way up to 4, and we include it. Next objective. Solve absolute value inequalities. Okay, so properties involving absolute value inequalities. This is found on page 149. Oops, I already wrote that. Awesome. Okay, I wrote that right there. So for real number k, we have two options. One, we have an absolute value with some value inside called u, which is less than our number k. We can translate this into the statement negative k is less than u, which is less than k. So note here that the idea is that we're trying to get rid of our absolute values. Okay. So we're trying to find a way to rewrite it without the absolute values. So if you're given a problem that looks like an absolute value, your goal, get it into something that does not have an absolute value. Now there's another option, that u is greater than k. To get rid of the absolute value of u is greater than k, how we translate this is u is less than negative k, or u is greater than positive k. So notice, main difference here. It's less than the negative, or it's greater than the positive. Now when you write out problems with this, you need to include or. It's very important, and if it's not there, you might be missing a few, probably only like a half point, but there would be some deductions. And note, this holds true for the equal sign symbols as well, the inequality equal sign. So now, solve the following absolute value inequalities. Well, I see the absolute value, but it's not by itself. Is that a problem? Yes, it is. So notice, in order to do the translation, it needs to be by itself. So that's going to be our first goal. Get it by itself. So what's keeping it from being by itself? Well, that 2 and the negative 3. As usual, get rid of the subtraction or addition first. So add 3 to both sides. Do we need to flip the sign? Nope. Now getting rid of that 2, we'll divide both sides by 2. Absolute value of 6 minus m is less than 5. Awesome. Now we have the absolute value by itself. So the question is, which option is this? 1 or 2? Well, a good way that I use to remember it is by this word here, goal. This tells me, notice if you're looking at your absolute value on the left side of your variable, if your absolute value is greater than, you're going to use or. If your absolute value is less than, you're going to use an and statement. Let's see if this works. My absolute value is less than, which means I should technically use an and statement. Does that make sense? Let's see. Yep, that's an and statement right there. Let's go ahead and use that. So if this helps you, go ahead and use it. If not, if you can just memorize this straight up, awesome. Okay. So translating. Well, here, u is whatever is inside my absolute value. So for this problem, u is 6 minus m. So we're going to rewrite this. It says we take our u value, put it in the middle, so 6 minus m, and then we take our k value, which in our case, k is 5. Let me just go ahead and color code this. So my u is less than 5, so it looks like we just copy pasted that down, but it's greater than the negative. Okay, awesome. Look, we have successfully translated without the absolute value symbols. That is an awesome step. Now, let's just go ahead and keep solving. So get rid of that 6 on the inside. Remember, we have to do it to all 3 sides. So then we have negative 11 is less than negative m, which is less than negative 1. Continuing our work over here. I'll just copy it down real quick. Ooh, we have that negative m. Got to get rid of that. So multiplying by negative 1. When I do that, the signs all flip. We have 11 is greater than m, which is greater than 1. All right, let's go ahead and graph that. 0, actually, 0, 1, 11. My absolute value says m is between 1 and 11. So I'm not going to flip this equation like I did last time. I'll just leave it as it is. M is between 1 and 11. These are my m values. And writing this as, well, actually it doesn't tell me to write my final answer in absolute, or in interval notation, but I'm going to go ahead and do that anyways. Good practice. This is 1 to 11. So my answers. Let's take a look at the next problem. Oops. Okay, go ahead, pause the video, try solve this one by yourself first, see what you get. Well, one thing I noticed first is that my absolute value is on the right side this time. So what I'm just going to flip my equation. I'm not going to change anything, I'm just flipping it. So notice the absolute value is on the left-hand side, or the less-than side. So I'm going to keep everything the way it was. Check to make sure. Is the narrow side near the absolute value? Yes, it is. Awesome. Okay, this looks a little better. Now let's go ahead, divide both sides by negative 3 to get rid of that negative 3 on the outside. Ooh, when I do that, gotta flip the sign. So absolute value of 2y minus 4 is greater than 18 divided by 3 is 6. Now what kind of a statement this is? This is greater than, because my absolute value is greater. So, with the greater than statement, the question is how do we translate it? Well, let's use goal. G for greater than, that means I'm going to use an or statement. So translating, this is the translation step. Remember, it's an important step. The or statement. I just copy paste first, so 2y minus 4 is greater than 6. Or, you have to write that or, 2y minus 4 is less than the negative 6. Okay, let's take a look. Does that, how we're supposed to copy it? U is less than negative, yep. U is greater than the positive, yes, that is what I did. Notice it's slightly swapped to the way the directions were, but that's okay. As long as you keep your inequalities with the correct sign. So the less than should be with the negative, The greater than should be with a positive. Let's go ahead and solve both sides. Add 4 to both sides. 2y is greater than 10. Dividing by 2, we get y is greater than 5. And on the other side, add 4 to both sides to get rid of that. We have 2y is less than negative 2. Dividing both sides by 2, we have that y is less than negative 1. And this is an OR statement, so I'm going to go ahead and include that in the very end. Bring down that OR. Oh, very important right there. Actually, I really should include that in the answer. So I'm going to go ahead and erase this so I can include the OR in the answer. There we go. It's part of the answer. So if I was to graph this, what would it look like? I have 0, negative 1, and 5. What do I know? Well, I know that y is greater than 5, or y is less than negative 1. So that's what it looks like. Okay, if I was to do interval notation, what would that be? Try pause the video and see what the interval notation would be. So interval notation would be go negative infinity to negative 1, not including, union 5 to infinity, closed. And that would be our answer. Now let's take a look at some special cases of absolute value inequalities. So first one, we have x plus 2 is less than negative 4. This is saying an absolute value is less than a negative number. Does that make sense? Because remember, absolute values are always positive. This statement is saying there's a positive number that is less than negative 4. That does not make sense. So what would I answer? My answer would be, there is no answer. So you could just say the empty set is your answer. There is nothing inside of it. Don't put a 0, by the way. There is nothing inside it. It's the empty set. Let's take a look at the other example. We have x plus 2 is greater than or equal to negative 4. This is saying a positive number is greater than a negative number. Well, every number is greater than a negative number. So my answer would just be all real numbers, which could be the bolded r, or you could do negative infinity to positive infinity as your answer. Let's take a look at the other special case. X minus 5 is less than or equal to 0. Well, we know that an absolute value cannot be less than 0, right? It can't be negative. So the only option is that x minus 5 is equal to 0, because it can't be less than 0. And we can just drop those absolute value signs. And solving, x is 5. So our answer would be x equals 5. Now let's take a look at the last one for the special cases. X minus 5 is greater than 0. Well, the only time the statement would not be true is if x equaled 5. Because if x equals 5, we have 5 minus 5, which is exactly 0. But notice this problem is telling me it can't be equal to 0, but it could be greater than. So this is actually the solution set of every number except for 5. We can't include 5. Why can't we include 5? Because we don't have that lovely little equal to symbol down there. So it'd be every number except for 5, which in interval notation would be 5 union 5 infinity. Okay. Objective 4. Solve applications of inequalities. Emily has test scores of 96, 84, 80, 98, and 88. Her score for online homework is 100 and is weighted as 1 test grade. Emily still needs to take the final exam, which counts as 2 test grades. What score does she need on the final exam to have an average of at least 90? Well, what do we want? She wants to have the average of all her scores to be greater than or equal to 90, because that's what at least means. The smallest it can be is 90. And what are we trying to find here? Remember, we need a let statement. It wants to know what score she needs in the final. So let's let x equal score on final. Well, if I want to find an average, what you do for an average is you add up all the values and you divide by how many there are, right? So let's do that. We're going to add up all the values of her test scores. So she has 96, 84, 80, 98, and 88. Ooh, that looks like a G. But notice her homework counts as a test grade. So we're going to plop that in too. And then her final exam, it doesn't just count as one grade, it counts as two. So how can I represent that? It's two test grades. So remember, so for example, if she got an 80 on her final exam, we would count it twice. So how can I represent that with x? Well, I would just write that as, remember, like 2 x's, because I'd count it twice. And then we're dividing by the number of items we have, because remember, we're taking the average. So 1, 2, 3, 4, 5, 6, 7, 8 items. Now let's simplify this. I'm going to add those x's together. So we have 96 plus 84 plus 80 plus 98 plus 88 plus 100 plus 2x all over 8, is greater than or equal to 90. Now I'm going to add up all of these number values, and calculating those out, that comes out to 546 plus 2x all over 8 greater than or equal to 90. Well, we're solving an inequality. Let's get x by itself. So I'm going to multiply both sides by 8 to cancel out the 8. And I have 546 plus 2x is greater than or equal to 720. Let's carry our work on up to the side. Let me just rewrite it. 546 plus 2x is greater than or equal to 720. Now subtract 546 from both sides. We get 2x is greater than or equal to, let's see, 720 minus 546, 174. Almost there. Dividing by 2. X is greater than or equal to 87. So what does this mean? Well, the score she needs on the final is an 87. Or at least an 87. Emily must score at least an 87 to earn an A in the class. Alright, look at her. She's calculating out her grade by herself. I used to do that too when I was in my classes. Okay. Example 6. Suppose that a machine is calibrated to dispense 8 fluid ounces orange juice in a plastic bottle with the measurement error of no more than 0.05 fluid ounces. Let x represent the actual amount of orange juice poured into the bottle. Write an absolute value inequality that represents an interval in which to estimate x. So basically this is saying that there should be, so let's say I have some bottles of orange juice, right? Trying to draw the bottles. That one's like a hunchback bottle. Okay. So we're aiming to have 8 fluid ounces. Let's say this is exactly 8. But it's saying that there is a measurement error of no more than 0.05 fluid ounces, which means that we could have one that's slightly less than what the amount should be, and one that is slightly more than. What's the most it could be less than? Well, the most it could be less than would be 8 minus 0.05, which would be 7.95. And what's the most it could be? Well, it'd be 8 plus 0.05, which would just be 8.05. So that's what it's saying. It has this range, and then it could be any other value in between these two. But that's the smallest amount it could be, and that's the maximum amount it could be. So this is just a drawing. Let's solve this algebraically. So write an absolute value inequality that represents an interval in which to estimate x. Well, we know that however much we have, if we take away 8 from it, we should fall no greater than or no less than 0.05. All right. Because you could possibly be a little greater than 7.95 or a little less than 8.05. Okay, so solve the inequality and interpret the answer. Let's go ahead and solve. So x minus 8 less than or equal to 0.05. Well, it's already by itself, so let's go ahead and translate this. Using goal, that's less than, which means I'm going to use an AND statement. So just translating directly into an AND statement, and remember, to solve absolute values, you need to do the translating step. So whenever you see an absolute value and you're trying to solve, think translate. Okay, so x minus 8 less than or equal to 0.05. Let's go ahead and solve. So add 8 to both sides, and we get 7.95 is less than or equal to x, which is less than or equal to 8.05. And what do you know? Those are the values that we did on the side. Oops, sorry for the screen going all weird. Those are the values we did on the side by using our little graph to check. So we could go ahead and box this as our answer. Now I need to actually interpret the answer. This is saying the amount of fluid ounces, the smallest it could be is 7.95 fluid ounces, and the largest is 8.05. So let's write that up. What did you say? Smallest? Yeah, sure. The smallest number of ounces, fluid ounces, allowed is 7.95 fluid ounces. The largest number of fluid ounces allowed is 8.05 fluid ounces. Remember your units, your period, and your capital letter. Okay, there we go. We have translated it. Now notice, I was actually able to figure out the problem by just using a graph, or a little chart here. But sadly, because you're told to find the inequality and create an inequality, that's what I'd be grading you for. So if you are able to figure out the answer on the side, this is great because you can then check your answer to make sure you got the right one. So sometimes it's always good to figure it out on the side and then find a way to algebraically represent it. Depends on what works for you. Okay, please email me if you have any questions.